All these are estimates of the time. So, if I wanted to know the time, suppose you have the whole population and there is some mean time from all your populations. That mean time I don't know. Right, so I just decided to pick one of you and ask you what the time is and use that as an estimate of what that means. Right, so I ask Amol, for example, pick Amol and say he gives me some number. Then I pick Aniket. I'm just picking a sample of size 1. These estimates will vary. Right, and they vary just as much as the population. Now I decide to do one thing. I decide to pick 2 of you at random and combine the information in what you tell me. So I say, Sagar has given me some information, Amol has given me some information. There are 2 different estimates. Let me put them together into one information bit by combining them. Which is, I say 0.5 into her, so I take a midway between her estimate and his estimate.
So average you are taking now?
I am taking average. So it's midway. So 0.5 x1, 0.5 x2 is x1 plus x2 upon 2. Right? So I take an average. Now that average is using 2 independent bits of information. So because it's got double the information, it will be twice as reliable as just using 1 bit of information. So twice as reliable, the variance of that must be half the variance of the original when I was using only 1. So if I increase the sample size, the reliability of my estimate must increase by the factor of the sample size, or the variance of the distribution of x bar should be sigma square upon the sample size. Because x bar actually uses n independent bits of information about an unknown quantity. Right? So I'll just show you how it works here, just to show you geometrically. Right? Yeah. Yeah, come. Tell me.
Here, variation of the sample is...
variation of the population is sigma square.
Right. So here, what does it end up?
It says that the variance of the sample mean will be sigma square upon n. Right?
Okay, that's not what you just said.
Yeah. Okay, so let me just show you how it works. Right? Okay, let me say, let x be, so it will be a Poisson distribution, not a normal distribution. There is a distribution called Poisson distribution. Right? So I have got a very large number, which is 4 degrees of freedom. Right? And see how my x looks like. Yeah?
The 4 is the mean.
4 is the mean. So my plot density will look like, so this is how my density looks like. Yeah? Sure? And it reaches a peak at 4. In fact, it can be shown that 4 is the mean and the variance of this distribution. The mean and the variance is the same for Poisson. Right, so 4 is the mean and the variance of distribution. This is my sample population. Is my population normal? I think no, it's not normal. It's got a pitchfork kind of a thing, no?
Spike.
Yeah, so it's not normal. Now what I'm going to do is I'm going to take a sample of size, say 1000 from this population, and I'm going to create a mean of a sample from X. Right? So I'm going to take a sample of size 1000 from this population.
Is it showing?